Okay, so this is our last lesson on absolute value, and you can see a little Eckert there saying, today I will understand how to solve absolute value inequalities. Okay, we've solved absolute value equations, but this time we're solving absolute value inequalities. So first thing we're going to do is a quick review, and I just want you to remember that the way that we look at this is that right there. The absolute value is the distance Eckert runs. Okay, so if I run 5 miles this way, where do I end up at? I end up at 5 number lane. We know that x equals 5. But we can remember that's not the only way I could run. I could also run this way, and that's 5 miles. So we know that Eckert also ends up at -5 number lane. And that gives us two answers. An absolute value, a distance that I run, can leave us at 5, and it can leave us at -5, both of those. And this is how an inequality is different. With an inequality, we don't know how far I run. We just know that I run more than or less than a certain distance. Okay? We don't know exactly how far, but we know that I'm running more than or less than a certain distance. And let's take a look and see how that works. Here's an example. The distance Eckert runs, is greater than, more than 3 miles. Okay? So that means that if I run this way, I'm going to go anywhere past 3 number lane. Okay? I might stop here, I might stop here, I might stop here, I might keep going, but I'm going to go anywhere past 3 number lane. So if you see me running, I got to run more than 3 miles. I don't stop here, I don't stop here, and I do not stop here. I have to go past it. So I am running greater than 3, because 4 is greater than 3, 5 is greater than 3, and so on and so on. Okay? But remember, that's not the only direction I can run. I can run this way. And I'm not going to stop here. I am not going to stop here. I'm going to go past. So I might go to -3.5. I might go to -4. I might go to -5. I might go to -10. But I have to run more than 3 miles. So there's 1 mile, there's 2 miles, there's 3 miles. But I might go here. And if I go there, I want you to notice something. I've run 4 miles. But look where I ended up. I ended up at -4. Okay? And this number right here, -4, is actually less than -3. Notice how the sign is different. Okay? That number is actually less than -3. And if I went 1 more mile, and if I went 5 miles, that would be perfectly fine too, because it's more than 3 miles. But look where I ended up. I ended up at -5, and that number is less than -3. Less than -3. So look at my two answers. All of these numbers over here, or these numbers, are less than -3. So what we got here, we got x is less than -3, or x is greater than 3. Okay, so my answers are either less than -3, such as -4 and -5, or my answers are greater than +3, such as 4, 5, 6, 7, 8, 20. Even if I ran all the way to 20 number lane, that would be greater than 3. And even if I ran all the way to -20 number lane, that would be less than -3. It's less than. This number is less than that number. Okay, so let's look at another example. I'll go through it step by step. Okay, the absolute value of x minus 2 is less than or equal to 1. The distance Eckert runs is less than or equal to 1. Okay? Distance Eckert runs is less than or equal to 1. So, let's take a look at the possibilities. I could run here, 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 here. I could stop there. It's less than 1. Here, 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 here. I could stop there. It's less than 1. Or I could stop here because it's equal to 1. Okay? So I can run anywhere in here. Less than or equal to 1. But remember, I could also run this way. Okay? So I can run anywhere in here. All right, now I know that there's no house here. All right, I know that that we don't have a house here at 1/2 number lane. Sorry, negative 1/2. But we know that this is negative 1/2. So let's say I ran to there. Let's say I only ran to negative 1/2. Well, look where negative 1/2 is. Negative 1/2 is actually greater than negative 1. Negative 1/2 is a bigger number than negative 1 because it's closer to 0. It's a bigger number. And then look at positive 1/2. Positive 1/2 is actually less than positive 1. Less than positive 1. So here's my possibilities. X minus 2 is less than or equal to 1. X minus 2 is greater than or equal to negative 1. And I hope that here's what you're noticing about absolute value with inequalities. I hope you're noticing, okay, that when we get this, we start off with the same sign, and then when we switch to negative, the sign switches. We start off with the same sign. This is exactly the same as this. But then when we switch to negative, the sign changes. It changed to greater than. So I add 2. I add 2. X is less than or equal to 3. I add 2. I add 2. X is greater than or equal to 1. And there's my answer. Okay, there's my answer. So what I'm going to do in part 2 is I'm going to check that answer. I'm going to check that answer to make sure that it works. And then we're going to do another example.